We have discussed the Rayleigh theorem. Now we are going to discuss Lagrange mean value theorem. We will prove it using Rayleigh theorem itself. So Lagrange mean value theorem says if a function f defined on the interval a to b is continuous on the closed interval and derivable on the open interval, then there exists at least one real number c between a and b, c lying between a and b, such that fb minus fa upon b minus a equals to f dash c. So I will tell you geometrically what does it mean. So suppose you have the function. So this is a point, say AFA, right? And say this is the point, say this is BFB, alright. Now what is FB minus FA by B minus A? This will be obviously slope of, this will be the slope of the line joining these 2 points, right? Or I should draw it, the slope of this line. Now it says FB minus FA upon B minus A is the slope of this line joining these 2 points. The Lagrange mean value theorem says if f is a function between a to b, suppose the function is going like, say this is the function, right? It's a continuous function. At every point it is continuous, there is no break, neither there is a corner, it is derivable. At every point it is derivable. In that case they will always exist, they will exist a point, see, between a and b, will always have a point between a and b. This is a, x equal to a, this is x equal to b. So they will lie a point c such that if I want to find, they will lie a point c such that f dash c, they will always exist a point such that the derivative of function at that point, the derivative of the function at that point, always exists a point c. See, this is the point c such that the derivative of the function at that point, derivative of the function at that point, that is slope of the tangent, is equal to the slope of this line. Derivative, there will always exist a point c between a and b such that the slope of tangent is equal to slope of this chord joining a and b. So this is point a and b. There will lie at least one point between a and b where if I draw the tangent at that point, then slope of this tangent is same as slope of this chord, or I can say tangent will be parallel to this chord. Tangent will be parallel to the chord, and tangent, the slope of tangent is represented by f dash c, means slope of this line and slope of this line will be same, they will be parallel to each other. So there will always exist a point. You can have more than one point also. Suppose the function is going like this, then you have more than one point where you find the tangent parallel to the chord. So at least there will be one point, at least there will be one point where if I draw the tangent, it will become parallel to the chord, means slope of this tangent, that is f dash c, must be equal to slope of the chord, right? See, you will find that Rayleigh theorem is special case of this. Suppose this fa is equal to fb. In that case, this is fa, suppose this is afa and this is bfb, and if fa is equal to fb, in that case the slope of the chord is 0, it makes 0 angle. So they will lie at least one point such that the slope of the tangent will be 0, or tangent will be parallel to this chord, or it will be parallel to x-axis. So if fa is equal to fb, this Lagrange mean value theorem will give way to Rayleigh's theorem, right? I'll try to do the proof also. Let me prove this Lagrange mean value theorem. This is important, extremely important for your exam. So Lagrange mean value theorem says if a function is continuous on the closed interval a to b and derivable on the open interval a to b, then there will at least exist one point, one real number between A and B, such that the tangent at that point is equal to is parallel to the chord joining the 2 point AFA and BFP. That's what this means. This is slope of the chord, this is slope of the tangent, right? There will exist at least one point. Now let's prove it. Let's try to do its proof, right? Here let us consider a function. Say let's consider a function gx equals to fb. This is not fb, it should be fx, right? Let's take this function fx minus fa minus x minus a. It's a very tricky topic. X minus a into capital A. Let's take this function where a is chosen such that GB equal to GA. I am choosing A such that GB is equal to GA. A is a constant which is chosen in such a way that GB is equal to GA. Now see this function. This function is continuous over A to B. This function is derivable also because this is fx. This is a polynomial function. X minus a into a is a polynomial function. Fx is a function for which you are having the information that fx is continuous on AB. So derivable on the open interval. So gx, this is a continuous function. X minus a is also a continuous function. This is a constant. So sum of the sum of the two continuous function or difference of the two continuous functions is also continuous. Similarly, difference of a derivable functions are also derivable, right? So gx satisfy, gx is, I can say gx is continuous. I can say gx is continuous on closed interval and derivable on open interval. So, and also a has been chosen in such a way that GB is equal to GA. So there will at least exist one point such that G dash C is 0. There will exist at least one point such that your G dash C is 0. Or I can say G dash X, you can find G dash X. G dash X is F dash X minus A, or I can write G dash C is 0 means A will be equal to F dash C, and A has been chosen in such a way that GB is equal to ZA. So that will give you what? GB is FB minus FA minus X minus AA, and GA is 0. So A is, I can write, this is B only. So this is FB minus FA, B minus A. So I can say F dash C is A and A is F dash B, my FB minus FA, B minus A. So you find that there exists at least one point such that F dash C is FB minus FA upon B minus A. So this is the proof of Lagrange mean value theorem. We have proved it. This is the proof of